Welcome back to HVAC for Beginners. My name is Chris. In this episode, we're going to intro climate control phase 2, components of the refrigeration cycle or the system. We're going to be going over in this series the evaporator, the thermal expansion valve, the Copeland compressor, and what they do within the system. So without further ado, let's get to it. Get you a cup of coffee, a pen, a recording device, and let's get to these studies. Introduction to climate control phase 2, components of the refrigeration cycle. Now, in phase 1, we kind of went over the refrigeration cycle, its circulation and motion, and the components that set in it. In phase 2, we're going to go over 3, one of the most important ones, and we will go over the additional ones as well within the system. But these 3 are one of the main components and the most important components of the cycle itself. The evaporator is part of the HVAC system or the evaporation system. So let's kind of go over what it does in the residential sense. It does the same thing in a commercial sense, except at a larger capacity. But in a residential air conditioning system or an AC system, the evaporator is an essential component responsible for cooling the air that is blown into the living space. So basically, the air that you feel in your home that comes from your supply vents that are in the ceiling, and or if you're in a mobile home from the floor, that is the air that is going across the evaporator that cools your home. So basically, the evaporator itself, when air is going across it, pushes the cold air that is coming across it that the refrigeration is pushing through your thermal expansion valve, drops the temperatures down, and allows it to cool. Now, without the blower assembly blowing across the evaporator, it would actually turn into a block of ice because it basically would drop it below the freezing point. The evaporator coil is typically located in the indoor unit of the AC system and works by removing heat from the air that passes over it. As the warm air from your home moves over the evaporator coil, the refrigerant inside the coil absorbs the heat and evaporates into a gas. So in the process, when it comes across and there is a refrigerant flowing, it goes in as a low pressure liquid. But as the heat pushes across the bottom of it and goes across it, it turns into a low pressure gas. This process cools the air in which then circulates back into your home. The refrigerant gas is then transported to the outdoor unit of the AC system where it is compressed, release the heat absorbed by the evaporator coil. Overall, the evaporator plays a crucial role in the cooling process of a residential AC system. It is responsible for removing heat from the air inside your home and cooling it down before circulating back into the living space area. So basically, inside your home or the indoor system is where your system is lying for the indoor unit. So that would consist of either a gas furnace in the evaporator coil, or if you have an electric unit inside the system, instead of using gas, it uses electric heat strips. And then the evaporator is usually at the lower base of the system, but it's a one-pack system. And it basically will do the same thing as heating your home as a gas furnace, except instead of using gas, it uses electric. So let's go ahead and get into the fundamentals of the thermal expansion valve and what it does. And this is where we kind of go into detail with it. And this is what I was explaining to you in phase 1, that we go into detail over the thermal expansion valve because it plays a critical role within the system. Now, before I read it, I want you to look at figure 5. You have an internal equalized thermal expansion valve. This is what you would see connected in a series with the evaporator coil and be inside a casing. The one that says external equalized thermal expansion valve, you will find those on a lot of refrigeration systems where you'll see a black thermal tape that is wrapped around it to keep it cool because it has a sensing bulb on it. Now, when I'm talking about the sensing bulb, if you look in figure 5 on the left-hand side, you'll see a little, kind of a grayish bulb and a little coil that goes to it. That is your sensing bulb. And that sensing bulb has a little bit of refrigerant in it, and it is attached to the suction side of the evaporator, and it measures the refrigerant flow and the temperature range in it. As it heats or cools, the gas inside the bulb changes, and it tells the thermal expansion valve how to move the needle and seat inside it to move. If you look over to the right-hand side and take a look at it, we'll go over the components. Now, the power element, which is the capillary tube and bulb. On top is the diaphragm. And then on the inside, you have your push pin, you have your orifice, and then your superheat setting spring. Remember I told you that we superheat this? There's where your terminology comes from. You have on the right side your inlet, and on the left side your outlet. So when you're looking at the thermal expansion valve, you have two fittings. And if you take it and stand it up where the diaphragm is pointing upwards, the one on the right is always the inlet valve, and the lowest one is always your outlet valve. So that tells you which way the flow on that thermal expansion valve is designed. But let's go over its terminology. A thermal expansion valve, or TXV, is an important component of the air conditioning system. Its function is to control the flow of refrigerant into the evaporator coil. So when the line is coming from the outside unit, the first thing it's going to connect to on the high side is to the thermal expansion valve. That's where high pressure and low pressure makes its changes. As it said, its function to control flow of refrigerant into the evaporator is based on temperature and pressure of the refrigerant and the surrounding air. So let me go over a statement I made about older style evaporators that had capillary tubes, pistons, or flow raters, and that they were designed to absorb almost a standard amount of heat load in your home. The thermal expansion valve, on the other hand, can do more for that and is more efficient. So I'll give you an example. Say you were having that same party and your HVAC system had an expandable thermal expansion valve or an adjustable, and say you had planned for 20 people for your party, but 30 or 35 showed up. That extra heat load, because each person puts out 30 BTUs of heat per body. So you would times that by 30, and you've got all this heat load in your home. Well, the thermal expansion valve is designed to initiate a response because of the added heat load. It can respond and adjust and allow more refrigerant flow to come through to absorb that heat load to keep your home at a cool temperature. So then, if you maintain 76 degrees in there, it is more efficient to keep it there. Sometimes it might go a degree above that, maybe a degree and a half, but it still will keep your home at a comfortable level. The thermal expansion valve located between the liquid line and the evaporator coil, and it works by sensing the temperature of the refrigerant leaving the evaporator coil. As the temperature changes, the thermal expansion valve adjusts the flow of refrigerant into the evaporator coil to maintain a constant superheat, which is the difference between the temperature of the refrigerant and its boiling point at the given pressure. So refrigerant is naturally cold. Now, let me give you an example. If you sprayed it across your finger, you can get frostburn real quick. It's naturally cold. By controlling the flow of refrigerant, the thermal expansion valve ensures that the evaporator coil operates at its optimal temperature and pressure, which improves the efficiency of the air conditioning system. It also helps to prevent the evaporator coil from freezing, which can damage the system and reduce its performance. Overall, the thermal expansion valve plays a critical role in regulating the flow of the refrigerant through the air conditioning system, and it helps ensure that the system operates efficiently and reliable. So, just an overall breakdown, all systems today have thermal expansion valves on them. Refrigeration systems have thermal expansion valves on them, especially walk-in coolers and freezers. Now, the ones for the home, it makes it more reliable, more efficient, can absorb more heat load. It can transfer more refrigerant when needed by leveling the spring and adjusting the spring in the needle and seat in the orifice. It can adjust, either giving more or less depending on the heat load inside the home. So let's go over the outdoor system in which we talked about. Now you're seeing the system in the two pictures. The one on the left is a Goodman. The one on the right is a Train. As you can tell, it's significantly different in size, but the operations of the compressor or the condensing unit outside is the same. It doesn't matter if it's standard heat and cool or if it's a heat pump system. The one on the left is Goodman. Used to be Janitrol. They have come a long ways in their products, and their products are pretty good now. Train and Carrier are your Cadillacs of HVAC systems out there. They've been around a long time. Train actually runs their own compressors, but these units today run what's called a scroll compressor. Back when HVAC systems, when I started, they were called pot compressors, and what that means is it had a piston that driven up and down in it, just like it would be in a motor vehicle, and it would operate and compress just like that. It had its common start and run on it, like it normally does. It is a 220 system outdoors. That means your indoor unit can be 120 or 220, and then your outdoor is 220 volts. And it's real easy and real simple. It doesn't change unless you get into the commercial realm. There are some residential home units that are 223 phase. Most of your residential systems are 220 single phase, and we will go over the difference between single phase and three phase. Three phase is linked towards more commercial. The AC compressor is a key component of the air conditioning system, like in a vehicle or in a building. It is responsible for compressing and circulating refrigerant gas through the system. So basically, the compressor is the heart of the system. Without the compressor, the refrigerant can't flow. The AC system can't cool. Your home gets hot. Now, it refrigerates the gas through the system, which allows it to absorb heat from the indoor air and release it to the outside. That's why I told you, if you get a chance to go outside, put your hand over it while it's running, and you'll see the transfer of heat. The compressor works by drawing in low pressure refrigerant gas and compresses it into a high pressure gas. So basically, as it's coming back from the evaporator after absorbing the heat, it's a low pressure gas. When the compressor gets a hold of it, it pumps it at a hard rate. It increases its pressures up, and then the gas is sent to the condenser where it releases its heat and condenses back into a liquid. The liquid refrigerant then travels to the evaporator where it absorbs heat from the indoor air, cools it down, and sends the cooler back to the space. In short, the AC compressor helps remove heat and humidity from the indoor air and creates a more comfortable environment. To give you kind of an example, the relevant humidity inside the home, we tried, it basically reduces humidity in your home. 50% is about as best as they will do. So that's why there are times, if you ever go to a home, if you're visiting somebody and say you go in there and the air feels more, let me kind of get to the example. It feels cooler, kind of sticky to the touch, like if you touch their table, it seems colder. What they have done is they have introduced moisture into the system, because with an HVAC system, its whole design is to bring temperatures down and remove humidity out of your home. That's why when on a rainy, hot day, it's sticky, humid, 90% outside, but you go in your home and it's a comfortable 50, 48, 50 degrees of humidity or percentage-wise, and that's why it feels comfortable. Some people will introduce a system that moisturizes the air, and we'll get into that, what that's called. It's called a humidifier. Some people will actually turn on humidifiers in their home close to their AC system or the return air to introduce a little bit more humidity because their nose gets dry or they have allergy issues. But with these systems, they keep everything cool. Now, what you really need to know is these are three major functions, but let's kind of go over, some of the functions going through it. Remember, you have a liquid line dryer in this system. The liquid line dryer is a filter that catches trash within the system. And let me explain why it's so necessary. While it is a smaller part of the complete system, it is a vital part of the system. When the system runs for a while after years of operation, the copper inside there that runs through it will start to thin out and it'll break away, and that picks up trash. Refrigerant itself can get trashy after a while. There are things that happens to HVAC systems. Some compressors will fail after years of operation, and you can have what the terminology is called a burnout. What happens is the compressor windings short out on it. It burns it. It actually burns the refrigerant inside. And if you move it on your fingers, if you smell it, you spray it in your finger, it smells burnt. Well, that has collected some of that trash in there right as it was going through there, but doesn't collect all of it. And of course, we will go through what to do if you do have a compressor burnout, because there is important cycles to do that, because if you don't remove that refrigerant out of there and do a clean system check on it and add additives to it, you're going to burn out the new one that you put in. So that's the important play of that one. They do make a liquid line dryer for suction and for high side. Like I said, remember I told you, they're good for about 3 years. I like to go out, and when I install one, I'll actually take a black marker and mark the date and the year on when I installed it. So if I ever go back out there, or if another tech goes back out there, he can see it and be able to recommend a maintenance removal and replace of that when the time comes. Everything within the HVAC system has components that need to be replaced. Condensers outside, evaporators inside as well. Evaporators do fail and leak. Condenser coils fail and leak. Contactors and capacitors fail and go bad. Wires will burn out and short out. It's just part of the system. It is an electrical system. It is a refrigeration sealed system. So they can go bad after a time. If you sweat your copper on and don't do a good job, after a while it might pinhole a leak in it. That's why it's good to learn how to sweat copper. And we'll kind of go over that essential on that as well. That's real big and important. Matter of fact, one of the most important. Otherwise, you won't get your system to seal. But I hope that you're getting a good knowledge or a small starting as a beginner. I'm not expecting you guys to, after 2 or 3 videos, become an expert. That's not possible. But I can get you through this one. This is a refrigeration cycle. We did phase 1. Now we're in 2, going over the component. And the 3, like the 3 major ones, your condenser, which houses the condenser coil, all in a pack system, and your compressor. Your evaporator itself harnesses a thermal expansion valve in a package, and it goes inside the indoor unit. Those are 4 components that are in 2 systems that are sealed together. One outside, one inside. The only thing that separates the 2 is the copper lines that go from the evaporator to the condenser and goes through the cycle, and that is your refrigeration cycle. Starts from the compressor to the condenser, all the way to the thermal expansion valve to your evaporator, and then back to the compressor, and goes through the cycle over and over again. It is important to know one thing. The system needs to cycle at least 3 times an hour. If it's not going to do that, you can potentially cause damage to the system, and the compressor can go on thermal overload because it doesn't have time to really cool down. The refrigeration in the system is what keeps that compressor cool. Without it, it will overheat. If you go get a low refrigerant or a leak in the system, it will overheat, and or the evaporator will freeze up because it drops below the freezing point, no matter if there's air going across it or not. And we'll kind of get into troubleshooting with that one. Let's not get ahead of our game. I hope this helps you, get you a little bit more understanding. Go over the video as many times as you need. Make sure you leave a comment down below. Guys, subscribe and hit the notification bell so that you get notified when more of my videos go up. If you have a comment or a question about any of these videos, please leave it. I'll be glad to answer. I will get back to you as quick as I can. This is a training video. I have taught many courses, many classes. Everybody learns at a different rate. And everybody learns at a different style. And everybody can get this if they put their mind to it, and put hard work into it. You'll never fail. You'll become one of those great service techs that everybody's looking for out there. And you'll have customers who will specifically ask for you if you do a good job and you treat that customer right. This is Chris with HVAC Beginners. Till next video.